Ground fault circuit interrupters, or GFCIs, and leakage current detection and interruption devices, or LCDIs, are distinct electrical safety devices. They each serve a different purpose in protecting against electrical hazards. A GFCI protects against electrical shock by detecting imbalances in the current flowing between the hot and neutral wires. It trips when there is a difference in current between the hot and neutral wires, indicating a potential electrical shock risk. GFCIs are typically used in areas with high moisture, such as bathrooms, kitchens, and outdoors. In contrast, an LCDI protects against electrical fires by detecting small, continuous electrical leaks, known as arcing, in a circuit. It trips when it detects an arc fault, which can occur in loose or damaged wiring or connections. LCDIs are typically used in bedrooms, living rooms, and other areas where there may be a risk of electrical fires. There are key differences between the two. Firstly, GFCIs protect against electrical shock, while LCDIs protect against electrical fires. Secondly, LCDIs are more sensitive than GFCIs and can detect smaller electrical leaks. Thirdly, GFCIs are typically used in wet areas and outdoors, while LCDIs are used in areas with a high risk of electrical fires. According to the National Electrical Code, or NEC, room air conditioners that are installed after January 1, 2023 must have either an LCDI or an arc fault circuit interrupter, or FSI. An FSI also protects against electrical fires, but it is designed to detect different types of arc faults than an LCDI. Let's delve deeper into the specific functions of each device. A GFCI constantly monitors the current flowing in a circuit. It compares the amount of current flowing through the hot wire to the amount returning through the neutral wire. In a properly functioning circuit, these two currents should be equal. However, if there's a ground fault, meaning that some of the current is leaking out of the circuit and flowing to ground, perhaps through a person touching a live wire, then the current balance is disrupted. The GFCI detects this imbalance, which is typically a very small difference, like 5 milliamps, and quickly trips the circuit, cutting off the power and preventing a potentially fatal electrical shock. The speed at which a GFCI trips is crucial. It's designed to interrupt the circuit within a fraction of a second, fast enough to prevent serious injury. GFCIs are essential in areas where water is present because water significantly increases the risk of electrical shock. Common examples include bathroom outlets, new sinks, kitchen counters, outdoor receptacles, and unfinished basements. An LCDI, on the other hand, is designed to detect arcing faults. Arcing faults occur when electricity jumps between two conductors, creating a spark or arc. This can happen due to damaged wiring, loose connections, or worn insulation. Arcing generates heat, which can ignite nearby flammable materials and cause a fire. LCDIs are particularly sensitive to low-level, persistent arcing. They use sophisticated electronics to analyze the electrical waveform and detect the telltale signs of arcing. When an arc fault is detected, the LCDI quickly trips the circuit, preventing the arc from escalating into a fire. LCDIs are often used in appliances with long cords that may be subject to wear and tear, such as lamps and hair dryers. They are also commonly found in bedrooms and living rooms, where there's a high concentration of flammable materials like curtains, carpets, and furniture. The sensitivity of LCDIs is a key factor in their effectiveness. They can detect arcing faults that might not be noticeable to a standard circuit breaker. This early detection is crucial for preventing fires before they start. While both GFCIs and LCDIs are designed to protect against electrical hazards, they operate on different principles and protect against different types of risks. A GFCI is primarily concerned with preventing electrical shock by detecting ground faults, while an LCDI is focused on preventing electrical fires by detecting arcing faults. In some cases, a single device may incorporate both GFCI and LCDI protection. However, it's important to understand the specific functions of each type of protection to ensure that you're using the right device for the application. The NEC mandates the use of either LCDIs or FSIs for room air conditioners to address the specific risks associated with these appliances. Air conditioners often have long power cords that can be damaged or worn over time, increasing the risk of arcing faults. Additionally, air conditioners are often used in bedrooms where there is a higher risk of fire due to the presence of flammable materials. An FSI, or arc fault circuit interrupter, is another type of device that protects against electrical fires. While both LCDIs and FSIs protect against arc faults, they are designed to detect different types of arcs. An LCDI is primarily designed to detect low-level, persistent arcing, while an FSI is designed to detect a wider range of arc faults, including both low-level and high-level arcs. FSIs are typically installed in the electrical panel and protect the entire branch circuit, while LCDIs are typically installed in individual appliances or outlets. The choice between an LCDI and an FSI for a room air conditioner depends on the specific requirements of the application and the type of arc faults that are most likely to occur. It is important to consult the NEC and other applicable electrical codes to determine the appropriate type of protection for a given application. In summary, GFCIs protect against electrical shock by detecting ground faults, while LCDIs and FSIs protect against electrical fires by detecting arc faults. GFCIs are typically used in wet areas, while LCDIs are often used in areas with a higher risk of fire. The NEC requires the use of either an LCDI or an FSI for room air conditioners to address the specific risks associated with these appliances. Understanding the differences between these devices is essential for ensuring electrical safety in your home or business. When selecting electrical safety devices, it's important to consider the specific hazards that are present in the environment. If there's a risk of electrical shock, such as in a bathroom or kitchen, a GFCI is essential. If there is a risk of electrical fire, such as in a bedroom or living room, an LCDI or FSI is recommended. It's also important to ensure that all electrical work is performed by a qualified electrician and that all electrical devices are installed and used in accordance with the manufacturer's instructions. Regular inspection and maintenance of electrical systems are also crucial for preventing electrical hazards. This includes checking for damaged wiring, loose connections, and worn insulation. If you notice any signs of electrical problems, such as flickering lights, sparking outlets, or a burning smell, it's important to have them addressed immediately by a qualified electrician. By taking these precautions, you can help to ensure the safety of yourself, your family, and your property from electrical hazards. Furthermore, it's crucial to understand that GFCIs and LCDIs are not a substitute for proper grounding. Grounding provides a safe path for electricity to flow in the event of a fault, helping to prevent electrical shock and fire. All electrical systems should be properly grounded in accordance with the NEC and other applicable electrical codes. In addition to GFCIs and LCDIs, there are other types of electrical safety devices that can be used to protect against electrical hazards. These include surge protectors, which protect against voltage spikes, and circuit breakers, which protect against overloads. Surge protectors are designed to protect electronic equipment from damage caused by voltage spikes, which can occur due to lightning strikes or other electrical disturbances. Circuit breakers are designed to trip and interrupt the circuit when the current exceeds a safe level, preventing overheating and potential fires. When choosing electrical safety devices, it's important to consider the specific needs of your home or business. A qualified electrician can help you to assess your electrical system and recommend the appropriate devices to protect against electrical hazards. Remember that electrical safety is an ongoing process. It requires vigilance, education, and a commitment to following safe electrical practices. By taking these steps, you can help to create a safe and electrically sound environment for yourself and others. Finally, always remember to test your GFCIs and LCDIs regularly. Most devices have a test button that you can press to simulate a fault and ensure that the device is working properly. It's recommended to test GFCIs and LCDIs at least once a month to ensure that they are functioning correctly. If the GFCI or LCDI fails to trip when tested, it should be replaced immediately. By testing these devices regularly, you can ensure that they are ready to protect you in the event of an electrical hazard. To elaborate on the NEC requirements for room air conditioners, it's important to note that the specific requirements may vary depending on the edition of the NEC that is in effect in your jurisdiction. The NEC is updated every 3 years, and each edition may contain changes or revisions to the requirements for electrical installations. Therefore, it's essential to consult the latest edition of the NEC to ensure that you are complying with the applicable requirements. The NEC provides detailed information on the installation, wiring, and protection of electrical equipment, including room air conditioners. It also specifies the types of overcurrent protection, grounding, and bonding that are required for these appliances. In addition to the NEC, there may be other local codes or regulations that apply to electrical installations in your area. It's important to check with your local building department or electrical inspector to determine the specific requirements that apply to your project. When installing a room air conditioner, it's important to follow the manufacturer's instructions carefully. The instructions will provide information on the proper wiring, grounding, and mounting of the appliance. It's also important to ensure that the air conditioner is properly sized for the room in which it will be used. An undersized air conditioner will not be able to cool the room effectively, while an oversized air conditioner will cycle on and off frequently, which can waste energy and shorten the life of the appliance. Before installing any electrical equipment, it's important to disconnect the power to the circuit at the electrical panel. This will help to prevent electrical shock. It's also important to use the proper tools and equipment for the job. If you're not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. Working with electricity can be dangerous, and it's important to take all necessary precautions to protect yourself from electrical shock. In conclusion, electrical safety is a critical concern for everyone. By understanding the differences between GFCIs, LCDIs, and FCIs, and by following safe electrical practices, you can help to protect yourself, your family, and your property from electrical hazards. Remember to consult the NEC and other applicable electrical codes, and to hire a qualified electrician for any electrical work that you're not comfortable performing yourself.